So today we're going to cover section 7, and we're going to talk about linear inequalities in one variable. Now you probably have done this before in pre-algebra, and you probably did it again in algebra 1. Now when we solve inequalities, we're going to use the same rules that we do for equations, except when we divide or multiply by a negative number, then we're going to switch that inequality symbol in the other direction. Also know that when we write our answers, we're going to be graphing them, and we're also going to be writing our answers in interval notation. Now, what may be new to you is this interval notation. You've probably solved them before, and you've probably graphed them before. So let's go ahead and go over what it means to graph something on a number line and use interval notation. Now I notice it's got any number here, so I'm just going to go ahead and use the same number for the first 4 examples. Now when you have this symbol, the greater than symbol, or the less than symbol, when we go to graph it on the number line, it's going to be an open circle. So let's say I want to graph x is greater than 4, and then over here x is less than 4. I'm not going to go ahead and add all the numbers I need on my number line. I'm just going to put the number where I want the circle to be, right here in the middle of my number line. And when I want to graph x is greater than 4, it would be an open circle on the 4, and then my arrow points to all the numbers that are greater than 4. When I want to graph x is less than 4, again, it's going to be an open circle, but this time it's going to point to all the numbers that would be less than. Now, if it's easier for you to add more numbers to this, you could add a 3 and a 5. If that helps you out, you can add more than just the one number. Now, also what's going to be new is keep in mind that when it points to the left, this is going to negative infinity. That number line would keep going. When it goes to the right, it's going to infinity. So we're going to be using these symbols, infinity and negative infinity, in our interval notation. So interval notation, think about if you were to read your graph from left to right. So the first thing on this first graph that I encounter as I'm reading or going across from left to right is right here at the 4. So whenever the symbol is either a greater than or a less than, the grouping symbol around it is going to be a parentheses. If it's going to be a less than or equal to or a greater than or equal to, we're going to have brackets around the number. The infinity and the negative infinity will always get a parentheses around it. So for example, if I wanted to write this first inequality in interval notation, the first thing I encounter when I go left to right is the number 4. And then as I keep going across here, then I get to the arrow and it's pointing towards infinity. So comma infinity. Infinity always gets a parentheses. And because it's just a simple greater than symbol, the 4 also gets a parentheses. Now for the less than, again, if you wanted to think about reading this left to right, first thing I'm encountering is the arrow, and that's pointing towards negative infinity. And then as I keep going across, the next thing I hit is the open circle, so I would put the 4, and it would be from negative infinity to 4. So whenever it's a less than, it'll be negative infinity up to the number. When it's greater than, it'll be the number and then positive infinity. Now for the greater than or equal to or the less than or equal to, the interval notation is the same. The only thing we're going to change is make it a bracket. And then for the graph, it's going to be a closed circle. So let's say, again, I'm using the same number. So here it's going to be a closed circle, and all numbers bigger than 4 or greater than 4. And then with my interval notation, it's going to be 4, comma, infinity. and it's a bracket this time. So again, let's say I use the same number, but this time it's less than or equal to. Again, it'll be a closed circle pointing towards negative infinity. So then my interval notation, negative infinity, comma 4, bracket around the 4 because it's got the or equal to. Now again, the graphing part of this should be a review from pre-algebra or algebra 1. Again, what's new is this infinity stuff in the interval notation. Let's try the compound inequalities. So let me go ahead and give you numbers for A and B. So let's say the compound inequality here is 2 is less than x, which is less than 4. Now, what you can do is you could sort of think of this as two separate inequalities. So like you could think of, I'm going to graph this one. So let me just add my numbers here, 2 and 4. So if I were to graph that one, this would be open circle on 2, and then all numbers bigger than 2. Then if I were to graph this one, x is less than 4, would be everything in this direction. The answer to this problem is where it's both red and green. So the answer or the graph of this would be open on 2, open on 4, and joined in the middle. You don't have to show me the red and the green. Just know that when it's a compound inequality and it's a variable in the middle and then two numbers, the graph is always going to be a line segment. So really what the value of x is any number that's in between 2 and 4. So in interval notation, this one doesn't have infinities. This one's just going to be 2 comma 4. And because they're both simple less thans, it's just a parentheses. Now if it were less than or equal to, same numbers here. Only thing I'm going to change is it'll be a closed circle, and then it'll be brackets. Let me get rid of that gallery. Now the or, that's going to have the graphs pointing away from each other. Now, the ones that I just did, just like before when I showed you the red and the green on this one, you can also see this represented as x is greater than 2 and x is less than 4. So sometimes they're going to be joined with the word and. So whenever you see the variable in the middle, know that they want the answer where they both occur at the same time. However, for the or, let's do the same numbers. Let's do x is less than 2 or x is greater than 4. So again, if I were to graph this one, this would be an open on 2, pointing towards negative infinity. And then this one would be open on 4, pointing towards infinity. Now, when we write this in interval notation, we're going to have to bring back our set operators, which you probably saw in Algebra 1. We're going to use the union symbol. So we're going to say that negative infinity up to 2. And then this gap here, we're going to put a U here, union together with 4 to infinity. So the answers here are everything that is less than 2 together with everything that's greater than 4. So that's what that U represents. And then if I were to do the same numbers here, the only thing different would be a closed circle. And we would change the parentheses to brackets. So negative infinity up to 2. Remember, infinity always gets parentheses. And then 4 with a bracket to positive infinity. So this was just graphing the solutions and writing in interval notation. Now we're actually going to start solving our inequalities. Okay, so again, we're going to solve them just as if it were an equal sign. We need to get our letters on one side and then our numbers on the other. So I'm going to go ahead and subtract 5 from both sides. Not 5, subtract 3. You could have subtracted the 5, but I'm going to try to keep my variable positive. So then I get 2x minus 7 greater than 9. Then I'm going to add 7. Divide by 2. And x is greater than 8. And now, just like we practiced on the previous slide, we're going to graph this. So if it helps you to add the negative infinity and the positive infinity, put the number you just got when you solved right smack in the middle. And again, whenever it's greater than, it'll be an open circle, and it's pointing towards the right. In interval notation, 8, comma, infinity. Again, I need to get my variables on one side and my numbers on the other. So I'm going to subtract 2x. (5x minus 3 less than or equal to 7). Add 3. 5x is less than or equal to 10. Divide by 5. And x is less than or equal to 2. Again, I'm going to graph it. Put 2 in the middle. This time it's a closed circle on positive 2. And again, it's less than, so it's pointing to the left. And again, in interval notation, negative infinity up to the 2, but this time the 2 gets a bracket. You could go ahead and work with the 3 over 2. It's just negative 1.5, but I'm going to multiply my entire equation by 2. Let me just rewrite it here, just to clear the fraction. So I'm going to times all 4 pieces by 2 to get rid of the fraction. So this becomes 2 minus 3x greater than or equal to 2x minus 8. Now I don't have to worry about dealing with a fraction or a decimal. Now, I am going to go ahead and on number 3, I'm going to move my variable to the right this time. But when I go to do number 4, I'm going to move it to the left, but it's going to be negative and I'm going to have to reverse. So let me just show you that you can move the letter to the right. It still will work. So if I add 3x to both sides, 2 is greater than or equal to 5x minus 8. Now move the number to the left. And 10 is greater than or equal to 5x. Divide by 5. And 2 is greater than or equal to x. Now, when I used to teach this to like pre-algebra students, like 6th graders, they would always try to think of this inequality as being like the arrowhead, but that trick only works when the variable's on the left. So what you can do is, if you like to do that trick, move it around. Now, see how Mr. and I used to tell him, look at Mr. Alligator, and I would add teeth to this, or I'd tell him it's a Pac-Man. if he's eating the 2, he still needs to keep eating the 2 if you flip it around. Okay, so just remember, if you want to put the variable back on the left, just make sure that Mr. Alligator is eating that 2. All right, so now I can graph it. So 2, closed circle, now pointing, if you want to use the arrow, the inequalities like the arrowhead to tell you which way to point it, you can use the trick because we've moved the variable back. And now in interval notation, it's going to negative infinity up to the 2 with a bracket. Let's try number 4. It's got a fraction also. So I'm going to go ahead and multiply everything by 3 on number 4. I'm going to rewrite the problem. 2 minus 5/3 x greater than x minus 6. And I'm going to multiply everything by 3. So this becomes 6 minus 5x greater than 3x minus 18. Now I don't need to deal with a 5/3. Because if you tried to make that a decimal, that would be negative 1 2/3. And that would get kind of messy. Now, instead of moving my letter to the left and making it positive, I'm going to show you what happens when we divide by a negative number. So if I move the 3x to the left, I get negative 8x. Then I have to move the 6. And you can do either way on this. If you would have rather moved the 5 over, it works. Now I'm going to divide by a negative 8. This is where that exception comes in. When you're dividing or multiplying by a negative number, this symbol that's right here is now going to reverse. I'm still using my rules for integers. Negative 24 divided by negative 8 is positive 3. But now this symbol, because I divided by negative 8, just flipped around. And now I can graph it. Negative infinity, the 3, the positive infinity, open circle on 3, pointing to the left. In interval notation, negative infinity up to the 3, and they both get parentheses. All right, now, when we've always been solving these equations and the inequalities, we only had a left side and a right side. Now I've got a left, a middle, and a right. I need to do the same thing to all 3 parts. My goal is to get this x all by itself. So I need to move the 2 and the 5. The first thing I'm going to do is get rid of the 2, and I'm going to add it to the middle. I'm going to add it to the left, and I'm going to add it to the right. Got to keep the whole thing balanced. So then negative 4 plus 2 is negative 2. And then 7 plus 2 is 9. I now need to get still x by itself. So I divide all 3 pieces, left, right, and middle, by 5. So now my final answer is negative 2/5 less than or equal to x, which is less than 9 over 5. Again, I don't need to put a whole bunch of numbers on my number line. I'm going to go ahead and just make sure that I put them on here, least to greatest. If you want to put the infinities underneath those arrows, you can. And now, again, if you want to think of this as graphing it individually, really what we're doing here is this one. X is greater than 2/5, which would be closed circle here. And then this one, x is less than 9/5, open, going this way. When it's a compound inequality like this, the answer is where the line is both blue and green. So the final answer here would be closed here to open here. So really what we're looking for are all numbers that are in between -2/5 and 9/5. In interval notation, there are no infinities in this answer. It just goes from -2/5 to 9/5. 2/5 gets a bracket, 9/5 gets a parentheses. When you're doing this, you don't need to show me the graph of the blue and the green. As soon as you see it's compound like this, you should realize your answer is going to be a line segment. Now, if you prefer, instead of doing the same thing to the left, middle, and right, you could also pull this apart, and you could also have solved this. So you could rewrite it as 5x minus 2 greater than or equal to -4, and then do this side of it and do 5x minus 2 less than 7. And you can solve them individually. But it's a lot easier just to remember when you're solving this, just leave it compound. Whatever you do to the left, you do to the right and the middle. But if you'd rather pull them apart and do them separately, you can. Let's try number 6. Again, my goal is to get x by itself. So I'm going to get rid of the 1 first. And this is like lopsided. There we go. All right, so we're going to add 1 to the left, to the middle, and to the right. -2 less than or equal to 6x, which is less than 4. I'm now going to divide everything by 6. This will simplify to -1/3, and this to 2/3. Again, when it's compound like this, just make sure you're putting your numbers on here, least to greatest. Put the appropriate circle. This one's closed, this one's open, and connected in the middle. The interval notation would be -1/3 with a bracket, comma, 2/3 with a parentheses. So I'm going to subtract 7 from all 3 pieces. -6 less than 2x, which is less than 4. Divide everything by 2. -3 is less than x, which is less than 2. Go ahead and make your number line. Add your numbers onto it, least to greatest. And we would have an open circle on -3, open on 2, connected in the middle. Interval notation would be -3, comma 2, and they're both in parentheses. For number 8, I'm going to clear my fraction. Let me rewrite my problem. I'm going to multiply everything by a 3. I end up with -12 is less than or equal to 2 minus 3x, which is less than 15. So I distributed it to each one of the terms, all 4 pieces. Now I can begin isolating my variable. So I'm going to get rid of the 2 first. -14 is less than or equal to -3x, which is less than 13. I now need to divide everything by -3. Remember, when you divide by a negative, these symbols are going to reverse. So negative 14 divided by negative 3 becomes positive 14 over 3. Reverse the symbol, and now it's negative 13 over 3. Now, notice my answer here, it's now backwards. It's not least to greatest. So let me go ahead and fix that. So x is still in the middle. I'm going to move the negative 13 over 3 here and the 14 over 3 here. So again, realize that this Pac-Man here, he's eating this x, so make sure the same thing happens here. And then the same thing on this one. So now when I go to graph it, now it's all set for me, least to greatest. Negative 13 over 3, 14 over 3. And again, open here, closed here, joined in the middle. Interval notation, negative 13 over 3 with a parentheses, and 14 over 3 with a bracket. So when we're solving absolute value inequalities, just like before when we did the equations, we need to isolate the absolute value. Now, then this next part says, if the absolute value, that's what those two bars are, is a less than or a less than or equal to, it becomes an and. If it's greater than or equal to, then it becomes an or. So here's my trick for this. So I sort of exaggerate the words. So this is a less than, and I make it an and. These are gray, instead of greater, it's greater. They become ors. So whenever your symbol is a less than or equal to, it's an and. If it's a greater or greater than or equal to, then it's a or. So change the ER in greater to an OR for or. Because once you get the absolute value, you're going to have to add one of these words in between. So let's try it. So first step is to isolate the absolute value. It's already isolated. Next thing I'm going to do is look at that symbol. This is a less and. So I'm going to write my two problems and I'm going to join it with the word and. Now, just like before when we did the equations, we got to flip the sign. So I'm going to drop the bars, rewrite it as it is. This is a less and, so I'm going to put the word and then for the second problem, I make the answer negative, but I also reverse the inequality. So we actually have to do two things on that second problem. And now I solve them individually. Add 5. X is less than 7. And then I'll do this one. X is greater than 3. Remember, when you put them on the number line, you're going to go ahead and put them from least to greatest. Whenever it's joined with the word and, this is this compound inequality, you can also rewrite this, put the smaller number, the bigger, x in the middle. Notice how here, if you want to add the little teeth to it, with the 3, it's eating the x. With the 7, it's eating the 7. So you can also rewrite it like this. Maybe I shouldn't put the word or in there. So either answer here is acceptable. I'm not sure what WebAssign is going to look for. They're probably going to want the interval. So you would put a parenthesis 3, comma 7. And then here this is open, open, and joined in the middle. For number 10, this one's a greater or equal to, so we're going to do an or here. So drop the bars, put in the word or, flip the symbol and make it negative for the second problem. Solve them individually. And again, remember when they're two separate inequalities joined by the word or, these are going to be pointing out in opposite directions. Again, we need to put it on our graph least to greatest. So the negative 10 goes first, then the positive 4. So again, if you graph them individually, this is a closed circle pointing this way. This one is an open circle pointing this way. If you want to add the infinities, because now we need to write it also in interval notation. It's going to go from negative infinity up to the negative 10 with a bracket. The little hole here is the union. Parenthesis 4, because it's an open circle, to infinity.
Wouldn't the 4 be a closed circle?
Yeah.
Yes, thank you. Why did I do that? Thank you. Good catch. It is a closed circle, so this is also a bracket. I don't know why I graphed it with an open. There you go. Thank you. Let's try number 11. Pretty good. All right. Same thing. It's already isolated for us. This is a less and. So I'm going to do x minus 20 less than or equal to 4 and x minus 20, flip it and make it negative 4. So then here, solve this, add 20. X is less than or equal to 24, and add 20. X is greater than or equal to 16. Again, when you put this on your number line, put it least to greatest. This one's going to be a closed circle on 24 and a closed circle here, and it's joined in the middle. So if you want to write this compoundly, it would be 16 less than or equal to x less than or equal to 24, and then with the interval, put the two numbers in brackets. Again, remember, step number 1 is to isolate the absolute value. So before I can even begin making my two problems, I need to divide both sides by negative 3. Once you divide by a negative, remember your symbol reverses. And now it's a less and, make your two problems. Solve them. X is less than or equal to 6, and x is greater than or equal to negative 4. Again, when you put it on your number line, make sure you're putting it least to greatest. So if you want to write it like this first, close circle, close circle, negative 4 comma 6 in brackets. So again, my first step is to isolate the absolute value. So I'm going to divide both sides by negative 2. And I got to reverse. Now, before we start, whenever this number is negative, we need to stop and think. Remember when it was an equal sign, we would say no solution. Now, we know that anything that comes out of here is going to be positive, and it's always going to be greater than -2. So this answer is all real numbers. And you would write all real numbers as -infinity to +infinity, or you can write this, like the R with the 2 sticks. Let me do that a little neater. Or write out all real numbers. And then number 14, this is another special case. So whenever you see a 0 or a negative number, you need to stop and think. Yes?
So do you put all real numbers for if it's any number in the that's negative there?
Any number that you put in there for X will work and give you a true statement. Let's try the next one. Now, for this one, we know that the less than is never going to work. We're never going to get a negative number out of this. However, we still need to deal with the or equal to part. So the only thing I'm going to solve here is x minus 1 equals 0. Because if it were just this is no solution. We can't get a number less than 0 to make that true. So the only thing we're dealing with is the equal to part of this. So I'm going to add 1 and x equals 1. And that's my only answer. That's the only thing that would make that true. The next one is the same thing. Make sure it's isolated. It is. Remember, if I were to try to do something here, just the less than, we know that it can never be less than 0 because it can't be negative, so no negatives. So the only thing we're going to be working on here is the equal to part. So 2x minus 1 equals 0. Add 1. 2x equals 1. Divide by 2. And the only answer here is x equals 1/2. So the only thing that would make that absolute value inequality true is when x equals 1/2. We have one more scenario. One more special case. And this is when it's greater than 0. Now, what we need to figure out is what it can't be. So it can't be equal to 0, but it could be any number greater than 0. So what we need to do here is figure out when x, we don't want it to be a 0. So we would add 1. And divide by 2, x cannot be 1/2. So anything else is going to make that true. So it's all real numbers. Except when x equals 1/2. And the way that we're going to write this, here's our number line. We would put 1/2 here. It's going to be an open circle here, but then it's the entire graph, except that hole. So again, if it helps you to write the infinities, because we got to do a union here. Let me fix that. So the special cases are the hardest thing about the absolute value. So this goes from -infinity up to the 1/2. It hits that hole, it jumps over it, and then it starts up again. And that would be the interval notation for that special case. Now, just to show you one other example that's not on here. Oh, never mind. That's it. All right, so I will see you guys on Wednesday. Have a wonderful day. One extra example that's not in the notes, just to show you, let's say we have an absolute value that is less than a negative number. Again, stop and think, okay? We would never get anything out of the absolute value that would be less than a -3, so just stop and say that this is no solution. And then if it said to graph it, you would just show an empty number line. So that is it for section 1.7.